So in this lecture we're going to be talking about the crown fabrication process. And as a start to this, let's just first ask this question: what is a crown? So just to simplify it, a crown, you can think of it as like a cap, something that is going to cover the tooth 360 degrees, and it's going to provide protection or coverage over the top of the tooth. Okay. So this is an example of a crown that we see, and if you look, part of what we want to do as dentists is try to recreate nature and to restore back to the patient what they originally started with. So you can see some discoloration in this tooth here. We've prepared this tooth for a crown by grinding it down, and now we're making a cap that's going to fit over it to restore this tooth back to the way that it used to be. So there's three reasons why we would consider crowning a tooth. One would be just a loss of tooth structure. So if a tooth has been compromised, we want a crown that's going to hold it together. Another reason is going to be if we want to improve the aesthetics of the tooth. So if you want to change the color and make it look more natural, we can cover that tooth with a crown. Or the last thing is if we want to change the tooth contours. So each of these three things we'll explore in a little bit more detail as we go forward. So let's start with this idea of tooth structure. So sometimes we get in a situation where the loss of tooth structure will compromise the structural integrity of the tooth. And what is compromised is actually going to be the cusp. And we want some cuspal coverage of this tooth just so that it will prevent further breakdown. Okay, so a common situation is going to be where a tooth has had a previous filling that now has functioned sort of almost like a wedge in the tooth, and now the cusp tips become real thin, and because these are the areas that tend to take on a lot of the load, they become overloaded and will eventually fracture. So you can see in this picture that this cusp tip has fractured right off at the gum line. So this is a study that I wanted you guys to read, just discussing how restorative procedures affect tooth stiffness. So just to summarize this article, they took a bunch of second premolars, and what they did is they had this instrument that was able to load the tooth, and then they were able to put strain gauges onto this tooth to measure the amount that is being strained by this instrument as it's pushing down on it. Okay. So they went through two sequences of testing. The one I want to focus more on is here in table 2. So what they did is they started off with a tooth that was unaltered, and then they measured that stiffness there with those strain gauges. So this is at 100%. And then they went ahead and made modifications to the tooth, similar to sort of the life cycle of a tooth. So if you think about a tooth as it continues down its journey in life, it'll start off with maybe an occlusal preparation, and then later on that margin will fail, and then you'll have maybe decay in more surfaces now. So common then to replace that occlusal preparation with a larger filling, maybe a DO or maybe an MOD. So let's take a look at this chart and see what happens as more and more tooth structure is taken away from a tooth. So remember, we started with an unaltered tooth, so this is 100% relative stiffness. And when you just have an occlusal filling, this only drops about 20%. So if you think about the tooth structure, both marginal ridges are intact. So circumferentially, that tooth is still held together by its own natural tooth structure. But now, as you can see, as you drop some boxes and break through the interproximal, whether you just have a DO or an MO, or if you've gone through both marginal ridges and an MOD, you can see how precipitously that relative tooth stiffness drops. So by the time you have removed both proximal boxes or both marginal ridges, that tooth stiffness has dropped about 63%. Okay, so there's been a large compromise in the health of the strength of that tooth. So in order to better protect those cusps, we're going to end up putting a crown on that tooth to, if you want to visualize it, it kind of holds everything together because you've got the whole tooth reinforced circumferentially in 360 degrees. Okay, so let's answer this question. What are the causes of tooth structure? Well, we can start probably with the most obvious one, which is dental caries. So we know that this is an infectious disease that's going to result in the dissolution and destruction of calcified tissues. So this is a chart that just depicts how our pH level changes in our mouth. So we know that after we eat a meal or drink some soda, the acid level in our mouth is going to drop. And if it drops below this critical pH level of 5.5 for an extended period amount of time, we're going to have demineralization of that tooth structure. So if we're going to take a look at what our tooth is composed of, we know that it's broken up into enamel and into dentin. So if you look at the dentin, you'll see that this is mostly of organic makeup, meaning that this is pretty resistant to dissolution. By the time you get into the inner layer of the dentin, you'll see that this has a larger organic component to it. So once you've penetrated through the enamel and the bacteria has got into the dentin, we know that that caries process spreads very quickly. And if you remember from your operative class, you'll see that the decay will spread right along the DEJ, and it'll eat away at that tooth structure fairly rapidly. Okay. Another source of tooth structure loss is going to be this process that we called attrition. So if you take a look at this patient, notice how flat the teeth are. So this patient has been grinding down their teeth and has caused some tooth loss. So the process of attrition is the act of wearing or grinding down by friction. So when two things come together and then you rub them together, you know you're eventually going to get some wear of that tooth structure. Okay. So just to clarify this definition of attrition versus bruxism, attrition is when tooth structure has been lost due to friction. Bruxism is the act of grinding your teeth together. So in order to clarify this point, all bruxism doesn't always lead to attrition. So the scenario I'm thinking about is, let's say you have a heavy grinder, something that grinds at night, but you have given this patient a night guard. So they may be a bruxer and grind their teeth all the time, but they're not actually wearing down their teeth. Okay, so just pay attention to that point. So just pay attention to that little point of clarification. Okay, so attrition is not synonymous with bruxism, although they are very closely related. So just to summarize this idea of attrition, you can think of it as the grinding down by friction. All right, now let's talk about abrasion. Abrasion is going to be the wearing away of tooth substance or structures through some unusual or abnormal mechanical process. Okay, another way to say it is an abnormal wearing away of tooth by causes other than mastication. Okay, so in this example, this is actually a patient that had undergone radiation therapy for cancer. And as we know, with radiation therapy, patients have a decreased saliva flow, which put them at a higher risk of decay. So this patient actually was very aware of that and was extremely diligent in their oral hygiene care, however to a detriment. So if you look at the lesions along the gum line, these have actually been worn away due to toothbrush abrasion. So the patient, in their efforts to keep their teeth nice and clean, actually did more damage by rubbing and abrading the teeth with their toothbrush too aggressively. So other examples of abrasion may be somebody chewing on a toothpick, or somebody with habits like nail biting. So those are all unusual processes that aren't caused by mastication or by putting your teeth together. So if you're to simplify this definition of abrasion, you would think of it as the loss of tooth structure via unusual or abnormal mechanical processes. Okay, and another cause of tooth structure loss would be this idea of abfraction. So abfraction is this theory that due to biomechanical overloading of the teeth, you get the teeth to flex in a certain way, and it causes these dished out features. So if you were to look at this very carefully, you'll see a very sharp V-shaped lesion in this tooth. So this is characteristic of this theory of abfraction, where that continuous bending or the repeated bending of that tooth is going to cause the loss of tooth structure in a really defined V-shape lesion. So this is often contrasted by abrasion, where in abrasion oftentimes you don't see a very sharp distinction like you do here. So if you're to simplify the definition of abfraction, you can think of it as the loss of tooth structure caused by biomechanical loading forces. So the last cause of tooth structure loss that we're going to talk about is erosion. So erosion in dentistry just describes the progressive loss of tooth substance by a chemical process. And most frequently this is going to be some type of acid. Okay. So if you were to look at these examples here, the patient on your left, this has actually been a case in which the tooth surface has been eroded away by a patient's own stomach acid. So this is a bulimic patient that had presented to us, and then you can see the wearing away of the tooth, mostly on the lingual aspect of that of the teeth. Okay, and on the right you're going to find this is example of tooth structure loss or breakdown of the tooth via an extrinsic source of acid, which is going to be soda consumption. So this patient came to us and had reported that they had been drinking cans and cans of soda every day. Okay, so you'll want to know that acid erosion can come from different sources, either internally, we'll describe that as intrinsic, or from an outside source of your body, and we'll denote those as extrinsic sources of erosion. Okay, as we move on, and we can go back and ask this question, when does a tooth need a crown? Well, another reason is to improve aesthetics. So in dentistry, there's a huge cosmetic component to what we do. So a lot of times we'll want to take patients that look like this on the left, and they come in and they're not satisfied with the way that they smile looks, and we'll be able to change the color and shape of their teeth to improve their smile and get them back to the way that they used to look before all this dental work had been done. Okay, so here's some before and after pictures, and these are all cases that are done in our pre-doc clinic. So it just gives you something to look forward to as you study and prepare for your transition into clinic. Just another example of some aesthetic cases that we've done. So in this case, we've prepped the front 6 teeth, and we go through a wax up phase, and then we end up delivering these teeth into the patient's mouth. Okay. The last one that we're going to talk about is if we ever want to change the contour of a tooth. So we're going to get into this idea of a survey crown. And a survey crown is used in conjunction with a removable partial denture, or an RPD. So a lot of times patients come with multiple missing teeth, and one way in which we can replace those teeth is to make them a removable appliance that ends up hugging or using the other teeth for retention and support. So you can see in this example here we have a metal clasp that is part of this removable partial denture that actually hooks onto a neighboring tooth. So there's times in which we want to create or design a crown such that the contour of it allows for this clasp on a partial denture to be able to effectively clasp onto and help hold that prosthesis in place. So these types of crowns are called survey crowns, okay? Crowns that support removable partial dentures, and we're going to design them in a very specific contour. So this RPD class you're going to get later on in your second year here at the school. Alright, so let's quickly go through how to make a crown. There's a whole another video that goes in much more detail about each of the steps. So you're going to want to watch that as well to fill in some of the gaps in knowledge here. But basically what I want to do just for now is to give you a quick overview of just the main steps that it takes to make a crown. So like we said, a crown is a cap that fits circumferentially over a tooth. So one of the first things that we're going to do is to grind the tooth circumferentially. So we're going to have to grind it and remove all this tooth structure around it, plus a little bit on top to make room for our cap or crown. After we've done that, we want to make an accurate mold of what that tooth looks like. So as we're making this crown, we're not going to do it obviously while the patient is there. So if we had a replica of what the tooth looks like, well, we can take that into the laboratory and then take our time to go through all the laboratory steps of actually fabricating this crown. So we want a good mold of what that tooth looks like. And once we have a mold, we're going to turn that negative into a stone positive. So we're going to pour that into stone, and then we're going to end up mounting that stone replica onto this instrument called an articulator, which basically just simulates the opening and closing of your mouth. So the next step then is to wax up the tooth, and in doing so, we're going to add wax to that stone mold, and we're going to make it look like a tooth. So we're going to have a whole wax pattern that is in the shape of the tooth that we want it to look like in the end. So with that wax pattern, what we're going to do is pour what we call an investment material around it and basically embed it in this investment material. It's a stone-like substance, and with that we're going to eventually burn out the wax pattern and then sling a bunch of metal into that wax. So basically the process of turning the wax into metal is this process that we call casting, and that's how you get a metal crown. Okay. One of the things that we'll also touch upon is the different materials that we have to make crowns out of. The two crowns that we're going to learn initially is going to be a full metal crown, and then also a porcelain fused to metal crown, which has a metal substructure, but it's been layered with porcelain. So the additional step when making a porcelain fused to metal crown is obviously the application of porcelain to that. So the difference would be that the initial metal piece that we get back is going to have a cutback, meaning it's going to be smaller than what the final tooth is going to look like, because we're going to add a more aesthetically pleasing material that's porcelain onto the tooth to get it to its full contour of what that tooth should look like.